Think bridge piers are driven from above. Think again. Engineers first turned the seabed into dry land, and then let workers walk down, digging by hand right below sea level. But going in is easy. Getting out is another story. On the 19th century Brooklyn Bridge, workers collapsed the moment they emerged, in agonizing pain, and some died instantly. No one dared go down again. The entire project almost faced ruin. How did they eventually solve this? The final solution left all engineers today in silence. To understand this, we must first know how engineers make dry land in the sea. The device they use is called a caisson. You can imagine it as a massive steel room, open at the bottom and sealed at the top. This room is slowly lowered into the water, then pumps drain all the water inside. Workers step onto the actual seabed to work, with dozens of meters of seawater above, separated by just a steel plate. The entire system pumps high-pressure air continuously to keep it completely dry. And this pressure must be absolutely precise, which is the most terrifying part. If the internal pressure drops slightly, seawater rushes in within seconds, leaving zero time to escape. But if pressure gets a bit too high, something even crazier happens. A steel caisson weighing hundreds of tons will, like a champagne cork, be blasted right out of the water, the entire structure instantly ruined. Engineers must watch the gauges every second, tightrope walking between two disasters. And workers inside this tank, which could explode or flood at any moment, stay there for hours. The Brooklyn Bridge disaster happened the very moment workers left the caisson. As they stepped onto the deck, they felt fine at first. But minutes later, severe joint pain set in. Some collapsed in convulsions, some lost consciousness, and the worst died on the spot. Doctors were completely helpless. Some blamed toxic gas in the caisson, others called it a deep-sea curse. Panic gripped the entire project. Chief Engineer Washington Roebling refused to believe these claims. He went into the caisson himself to find the truth, only to get struck down too, leaving him paralyzed for life. But he didn't give up. Turning his bedroom into headquarters, he set up a high-powered telescope by the window, watching the site across the East River daily. He wrote down orders, line by line, which his wife passed to the crew. A bedridden engineer, using just a telescope, built the world suspension bridge then, and the mystery was finally solved. With an answer more shocking than any sea monster, the culprit was high-pressure air. Under high pressure, nitrogen dissolves heavily into blood. This itself isn't dangerous, but if pressure drops suddenly, nitrogen is like an open soda, rapidly bubbling up in blood vessels, blocking capillaries, causing severe pain or even death. This solution slowed down decompression. Decompress slowly in stages, giving nitrogen time to escape safely. This discovery saved countless deep-sea workers later, human problems solved. Nature had more in store. In January 1995, a powerful earthquake struck Kobe. The Akashi-Kaikyo Bridge was being built. Two main towers were already anchored, and the first pilot cable just pulled. Then the quake hit. The fault line ran right between the towers. As the earth shifted, the distance between them widened by nearly a meter. All prefabricated structures became useless. All calculated cable lengths failed. Such an error means tearing it down to restart. But engineers didn't Instead, they recalculated every structural node without dismantling any finished parts and redesigned the entire suspension system. The completed Akashi-Kaikyo Bridge turned out exactly 1 meter longer, becoming one of the world's most earthquake-resistant bridges. The quake didn't destroy the bridge.